So we have discussed quick recap of formulas related to alternating current. Okay, so now we'll do some numericals related to alternating current and voltage. Okay, so these are all your JE and CET questions of previous years. Okay, and there is one tricky question. It's not a numerical actually. It's a tricky question. So in a LRC circuit, the power dissipation is through inductor, capacitor, resistor, or both inductor and capacitor. Okay, that's the question. Okay, so let us say I have a inductor, I have a capacitor, and I have a resistor. Okay, I am supplying some AC voltage. Right. So they are saying that the power dissipation is through power dissipation is through L, R, C, L and C. Okay, this is A, this is B, this is C, this is D. Okay. So the correct answer here will be the R. Why? Because when it is inductor, okay, so your current will be this, your voltage will be this. Okay. So there will be a phase angle of 90 degree. Okay. This is for inductor. So this is for inductor. Okay. Similarly, for a capacitor, your current, if this is current, your voltage will be this. Okay. So it will be lagging by 90 degree. Okay. So this is for capacitor. This is for capacitor.
Resistor is in phase.
So resistor, your I and V will be in the same phase. Okay. So this is for resistor. Okay. And L and C, it will depend. Okay. If you have a circuit, this is your current, and this is your capacity voltage. Okay. And this is
Your inductive voltage.
and this is your capacity voltage. Okay. So whether so the phase difference will depend on the relative magnitude. The phase angle with the current will depend on the relative magnitude of VL and
Voltage.
VC. So so that is how the LC circuit will behave. So power dissipation, what is the equation? So in AC circuit, the power dissipation is nothing but VI cos phi. Okay. Cos phi. Okay.
Yeah.
So this cos phi is called, otherwise called as the power factor. Power factor. Okay. So in case of capacitor, it cos phi is nothing but your cos 90,
Yes.
which is equal to 0. Okay.
Yeah.
Similarly, in case of inductor again it will be cos 90, which is equal to 0. So the power dissipated through inductor is 0. The power dissipated through
Capacitor is also
capacitor
zero.
is also 0 because cos 90 is equal to 0. Whereas resistor, it is a
In
same
phase.
phase, so it will be, so the power dissipated is only through resistor, not through inductor
Inductor
and
or
capacitor.
capacitor.
Okay. So that's why this power dissipated through inductor and capacitor is called watt-less current, because the power factor is 0 there. Okay.
Yeah.
So the power dissipated is through resistor. That's the answer. Okay. Even if it is a LC circuit, which is a oscillator, they are also uh, it is a worthless current. Okay.
No power is
Hmm.
received.
Okay. So we'll do some numerical. So this is a tricky question. Okay. See, these are the questions which will take few seconds only. So you should never, when you don't have to solve anything in a second, you can answer. So these kind of question one should never leave. Okay. So there is another numerical. The question is like this: an electric motor. So in household device, we want to know what is the current passing through each device.
Yeah.
Okay, what is the current passing through each device? So we know the supply voltage. Okay.
220.
Hmm. So we know the wattage of this machine. Suppose we have a mixie in our house, we have a pump in our house, we have a TV, we have a refrigerator. So every
Range.
device in their specification, the wattage will be given. Okay. So the wattage will be given, and the supply, the household supply that you know. So it is you can find out how much current it is consuming in ampere. Okay. So how much current it is consuming in ampere, that it is necessary to find out,
Okay.
because that way you can suppose you have a battery in your house. Okay, if you know the amperage of that particular device, you can know how long the battery can last. Okay. So normally your battery will be giving us, say, ampere hour will be
Yeah.
their specification. So, for example, your battery, okay, you have a battery, okay, its specification may be 100 ampere hour. So, what does that 100 ampere hour signify? So, if suppose you have a mixie in your house, okay, you have a pump in your house,
Yeah.
you have a TV in your house, you have a refrigerator in your house, okay. So let us say this mixie consumes, let us say 5 ampere, okay, okay. Then your pump consumes 10 ampere, okay. Uh, your TV consumes, let us say, 5 ampere. Uh, your fridge consumes 5 ampere, okay.
Yeah.
So only considering these 4 devices, it will be consuming 25 ampere. Okay.
Yeah.
So this much ampere it will be consuming when these 4 devices are running at one go.
Yes.
So that means uh, your battery, when these 4 devices are working,
Will work for
yeah,
that.
your battery will last for like 100 ampere hour divided by 25 ampere.
4 hours.
So 4 hour it is going to last. So that's why it is important to know how much ampere each device is consuming.
To know how much time the battery will run.
Hmm. So now in this numerical, one device is taken, one electric motor is taken. So actually, pump means what? Pump means it is a motor only, because pump will be driven by a motor. Okay. So that motor needs electricity.
Yeah.
Okay. So they are given one numerical. They have asked like how
Electric
much
motor.
is the current passing through the electric motor. Okay. So we'll solve that.
I'll just check.
So the question is like this: an electric motor has effective resistance of 30 ohm. Okay. So you have an electric motor whose resistance is 30 ohm. Okay. And okay. And inductive reactance is 40 ohm. Okay. So inductive reactance is nothing but your XL, right?
Yeah.
Which is equal to is 40 ohm. That is the inductive reactance. If the motor is powered by a source with maximum voltage of 420 volt. Okay. So, uh,
Voltage.
let us say this is my voltage. This is my motor. Let us say this is my motor. Okay.
Okay.
So this supply voltage is
440
440 volt.
volt.
So these are the things we know. Then what is the maximum current? So what is the current consumed by this motor? Okay. So uh, you have to find the impedance here. Okay. So this is a circuit where you have a resistance and you have a inductance.
Inductor.
So this is inductive reactance. Okay.
Yeah.
XL is inductive reactance.
R plus omega.
So your Z you have to find out first, which is the impedance.
R square plus omega.
So in RLC circuit, instead of resistance, we call it as impedance,
Yeah.
right? So Z is equal to R square plus XL minus XC whole square root,
Yeah.
right? So R is 30 square plus your XL is 40 square, XC is equal to 0 or whatever, right?
Yeah.
So this is 900 plus 1600 square root, which is 2500 square root, which is equal to 50 ohm. So this is your
Net
Z.
resistance.
Okay. So you know your Z value.
You have to find I. V is equal to IR. That's it.
Yes. So your house, the maximum voltage is 420 volt. Okay. This is not the RMS voltage. This is the maximum voltage. Then find out the maximum current. Okay. So I max is equal to
V max.
V max divided by Z. Okay. So it will become 440 volt
By 50.
divided by 50.
44 by 5.
And so
8.8.
so it is
8.8.
8.8 ampere. Okay. So that should be the answer. The 8 point. Okay. So sorry, it is actually not 440, and the question is it is 420 volt. Okay. So in your book it is given as 420. Okay. This is 420. Okay. That is the max voltage. So this is your 420 volt. So if it is
8.4.
420, it will become
8.4.
8.4 ampere. Okay, so this resistance of the electric motor. Okay, so your electric motor is nothing but your motor winding. Okay, you will have conductors and how does a motor functions? It will reverse of a generator. Okay,
Yeah.
so when a current carrying conductor rotates inside a magnetic field, there will be a torque will get generated.
After every half cycle, there will be alternating current. So
Yeah.
there will be.
Yeah, so when a current, so motor means you will have some magnetic field, okay? So inside the magnetic field you have this armature or whatever. So you have this shaft, okay? So this motor will be rotating inside a magnetic field, okay? So when the rotor, this is your armature. So on this armature you will have your current carrying conductor, okay? So if you take a cross section from the side view, if you look at it from the side view, so you will have some conductors, right? You will have conductors, okay? So this current conductor, there will be current passing through this conductor, okay? So when a current carrying conductor rotates inside let us say this is north pole, this is south pole, or whatever. This is your magnet.
Yeah.
So when a current carrying conductor rotates inside a magnetic field, there will be a torque. So torque is what? Equal and opposite force is nothing but your torque.
Torque. Yeah,
Okay.
yeah.
So there will be equal and opposite force. There will be a torque and it will be rotating.
After
Right.
every half cycle, it will change its direction.
So that's how a motor works. Uh, so through these winding or through these wires, how much? 8.4 ampere current will pass.
Maximum current is passing.
Maximum current 8.4 ampere. So you can see a motor consumes just less than 10 ampere current. Okay. If motor consuming 10 ampere, then your TV will consume much less.
Yeah.
Okay, so like that, knowing say there are 10 devices in your house, each consuming 10 ampere. That means 10 into 10, 100 ampere. If your battery is of 150 ampere hour, that means it will last for 1.5 hour.
Yeah.
Okay. So that is one numerical that we have done on current consumption in a
Electric motor.
Hmm. So, okay. So we will try to do one more numerical. We will try to solve one numerical related to a LRC circuit. Okay. So the question is like this. The question is like this. So you take a picture of
Yeah,
it.
took it.
Okay. So let me draw the picture. So you have a LRC circuit, okay? You have a capacitor here. You have a capacitor here. You have a resistor here, and you have a inductor here, okay? So this is your circuit, and you will have a capacitive reactance of 30 ohm, okay? So this is your XC, which is equal to 30 ohm, okay? 30 ohm, okay? So you just remember that capacitive reactance, inductive reactance, their unit is ohm only, okay?
Yeah.
You know XC is equal to 1 by omega C is equal to 1 by 2 pi FC. FC. So this C will be given in farad or microfarad or whatever. Yeah. So after replacing that C value, whatever you get XC is in your ohm.
Yeah,
okay.
understood.
So your XC is equal to 30 ohm. Your resistance is equal to 44 ohm. So you have a resistance R is equal to 44 ohm, right? And you have a coil with, so you have a coil, so you have XL, that is the inductive reactance.
2 pi
okay.
XL.
So you have a inductive reactance, okay, of 90 ohm, okay, 90 ohm, okay. This is the inductive reactance. In addition to 90 ohm, you have a resistance also to this. Okay, so this you can say as this is R1, this is R2. Okay, so you have that as 36 ohm.
R2 is one more resistance.
This is pure resistance. This is a coil. So the coil will have inductance, but there will be some resistance also associated with a coil. Okay. Sometimes it is negligible, but sometimes
like
it will have
resistance
some internal. There will, because this is a wire only, okay. So when you convert it into coil, it becomes an inductor.
Yeah.
Okay, but there will be some amount of resistance in it also.
Yeah.
So that he has just given it for the purpose of solving the numerical. Okay. So so the question is the power dissipated in the coil. Okay. What is the power dissipated
In the
in
coil.
the coil? Okay, so that is the question. Okay. Okay. So to find out the power dissipated, you have to find out the current first. Okay. So and then um, the question is okay. So they are asking the power dissipated in the coil, means this is my coil, right?
Inductor.
So okay. So power dissipated in the coil means what is the power dissipated in this coil? Okay, that we have to find out. Okay, so power dissipated means what is equal to I square R, right? So first I have to find out what is my I, right? So I is equal to voltage by impedance, I know. Okay. So voltage in this case is 220 volt and 60 hertz. So this is normal our household voltage. 220 volt and 60 hertz. Okay.
Frequency.
So this is my voltage and frequency. Okay. So this is the 220 volt and 60 hertz. So first I have to find out what is my Z. Okay. So Z is equal to R square plus XL minus XL minus XC whole square square root. Okay. So now this R is nothing but there are two resistors, this and this. These are in series. So I just have to add those two things. Okay. So this R, capital R is equal to R1 plus R2 is equal to 36 plus 44 which is 80 ohm. Okay. So this is 80 square plus your XL is 90 minus XC is how much? 30. Okay. 30 whole square, right? Square root. Clear?
Yeah.
So it is 80 square plus this is 60 square root. Okay. So this become 6400 plus 3600 square root.
10.
Okay, which is equal to 10. Okay. So your impedance is equal to 10 ohm, right?
Yeah.
Is it
No,
right?
it's 100.
100. So your impedance is equal to 100 ohm. So you know your impedance is equal to 100 ohm.
220 by 100.
So your current is equal to
220 by 100.
220 by 100, which is equal to 2.2 ampere. So this is the current flowing. Okay. So now the question is the power dissipated through the coil. So this is my coil. Okay. So what is the power
Only
through the
that
coil?
R2 you have to consider as
See, the power dissipated through this capacitance is 0 because power dissipated through capacitance is 0. Okay. Then power dissipated through this coil because of the inductance contribution, it will be 0.
But because of R2 there will be some power.
So that power is nothing but your I into R2.
I square.
Yes, I square into R2. I square into R2. So your I square is 2.2 whole square into your R2 is equal to 36. Right? So this becomes 4.44 into 36. That is in watt or whatever. So
12 point.
36 into 4, so 144. So in that range it will come. Okay, so actually it is 2 ampere. Voltage is 220 volt they have given. Sorry, it is given as 200 volt. Okay, just let us to get the accurate answer. This is 200 volt. Okay, is it 200 volt? So if it is 200 volt, your this will be 200. So 200 by 100, so this will become 2 ampere. So if this becomes 2 ampere, it will be 2.0 whole square, right?
4
So it will be 4
into 36.
4 into 36 is equal to 144 watt.
Yeah.
So that is the answer. So just here the catch is they are asking what is the power dissipated through the coil. So this is the only coil. Okay. So the coils are represented like this. Okay. So what is the inductance? Why they make it as a coil? So the coil has a different function as compared to a resistor. Okay. So capacitor is used to store the charge. Okay.
Yeah.
And inductor is something which will prevent a change in increase or decrease in current.
Yeah.
That is the function of an inductor.
Tries to keep it constant
Yeah.
in the circuit.
Yes, yes. Okay, so this is another interesting numerical consisting of RLC and
LRC.
you know how to find out the current, and knowing the current, how to find out the power dissipated by the coil. Okay. So let us try to solve one more numerical on alternating current. Okay. You have taken a picture? Okay. Okay. This is an interesting question. 32. Okay. Question number 32. This is an interesting question. In a series LRC circuit, okay. So you have a LRC circuit. You have an inductor. You have a capacitor. You have a resistor.
All in series.
All are in series. So you have in a series LRC circuit, you have R is equal to 300 ohm. R is equal to 300 ohm. L is equal to 0.9 Henry. Okay. L is equal to 0.9 Henry. Okay. And capacitance is equal to 2 microfarad. Okay. 2 microfarad. Okay. So these are the things they have given. L is equal to 0.9 Henry. Capacitance is equal to 2 microfarad.
Resistance is equal to 300.
And resistance is equal to 300 ohm. Okay. So these are the things those are given. See, this will be a numerical of 4 marks. Okay. So you may take 6 to 7 minutes for it. That should be okay.
Yeah.
Right now.
Yeah.
So you will have how many? 25 questions. So 25 into 3, 75 questions, right?
Yeah.
Physics, chemistry, maths. So say for 75 questions, you have 180 minutes, right? Okay, so per question you are getting 2.5 minutes, right?
Yeah.
But you can somebody who is targeting for half the questions, let us say 150 marks, okay, for 150 mark 2.5 into 2, so 5 minutes you can have if you are attempting half the question, so 5 minutes. So out of these there will be some simple direct questions.
Yeah.
So if you take 2 minutes for those or 1 minute for those, so on an average you can take 6 to 7 minutes for this kind of questions also. That should be fine. Okay. So you have these are the three things which are given, and the the impedance. So they are asking for this kind of circuit, what is the impedance of the circuit? Okay. So what is the impedance of this circuit? Impedance of this circuit. Okay. So you know impedance is nothing but your R square plus XL minus XC whole square root. Okay. So you have to find out your XL and XC. So XL is equal to
2 pi FL.
So
If
here
they should give.
omega they have given. Okay. So another input is omega. Omega is equal to 1000 radian per second. 1000 radian per second. Okay. So XL is equal to omega L. That's all. You don't go it into frequency. Just XL is equal to omega L. So omega is your 1000, right?
Into 0.9.
Into 0.9. So it is already in Henry. You don't have to convert.
Yeah.
If it is in millihenry, you have to convert to Henry for SI unit. So this is like 900 ohm.
Yeah.
Right? This is your XL. Similarly, you have your XC, which is in 1 by omega C. Okay, that is omega L, whereas this is 1 by omega C. This is 1 divided by your omega is your 1000, right?
Into
1000.
2 into 10. We have to convert.
This is microfarad. That means you will 2 into 10 to the power minus 6 farad, right?
Yeah.
So this, so 1 by 2, then this will be 10 to the power minus 3, right?
Yeah. 10 power 3.
So 10 to the power 3 divided by 2, which is nothing but your 500. Okay. So your XC is equal to 500 ohm.
Yeah.
So you know your XL, you know your XC.
And
Now you have to find the impedance. Okay.
300 plus.
So this is 300 square plus your one is 900
minus 500.
So 900 minus 500 whole square root. Okay. So this 300 square is 300 square. So it is just you. So this will be 300 square plus 400 square. Okay. Square root. So which is nothing but your 500.
Yeah.
Right. So 500 ohm is the answer. So for this circuit, the impedance is 500 ohm. Okay. So we have solved some nearly 4 numericals. So now you have understood, like. So similarly, there can be questions on this resonance. Okay. So they will ask like
1 by 2 pi.
So resonance is what is the angular frequency when the resonance happens? So that angular omega is equal to just 1 by square root LC. Okay. And what is the frequency at
1
which
by 2 pi into 1 by
2 pi square root LC. So this is a very common question related to LRC circuit. So resonance happen in a LRC circuit when the impedance is minimum. And the current is maximum.
And omega C are same.
So when impedance will be minimum? When this term will be 0.
When both of them are
so when XL becomes equal to XC, that time resonance happens.
Same thing for oscillator also.
Same thing for oscillator. So this formula is important. This also you have to remember. And another important catch point is whenever you have millihenry or you have microfarad and all that, you have to convert it into Henry and farad to get the units in SI. So ohm is a SI unit of resistance or inductive reactance or capacitive reactance. So that you have to convert. Okay. So XL is equal to omega L, XC is equal to 1 by omega C. These are the formulas required to convert these millihenry or microfarad or whatever to ohm. So when you are writing omega L, so using millihenry and all, you get in, you find finally it is in ohm. Okay. So impedance unit, the impedance unit is ohm
Ohm.
only. Okay. Clear now?
Yeah.
Okay. So in next session we will solve some more. Okay. Okay. Fine. Thank you.